Let's sketch the Lewis structure of SO2, commonly known as sulfur dioxide. To properly sketch the Lewis structure of SO2, follow these steps. Start by creating a rough diagram. Illustrate the chemical bonds between the atoms. Identify and mark the lone pairs on the atoms. Check that both the central and surrounding atoms have a complete octet. Finish up by calculating formal charges, aiming for a stable Lewis structure with minimal formal charges. Before sketching the rough diagram, we will first calculate the total number of valence electrons and then determine the central atom. The total valence electrons in SO2 are determined by summing the valence electrons of each atom. Both sulfur and oxygen, members of group 16, possess 6 valence electrons. Thus, with 1 sulfur and 2 oxygen atoms in SO2, the total valence electrons calculation is 6 for sulfur plus 6 for oxygen multiplied by 2, resulting in a total of 6 plus 12 equals 18 valence electrons for SO2. When determining the central atom for SO2, prioritize placing the element with the lower electronegativity at the center, with sulfur having an electronegativity of 2.58 compared to oxygen's 3.44, favor sulfur due to its lower value. Consequently, for the initial sketch of SO2, position sulfur in the center and arrange 2 oxygen atoms on either side. A single chemical bond is represented by 2 electrons. Thus, position 2 electrons on the left side to indicate the chemical bond between sulfur and the first oxygen. Similarly, place another 2 electrons on the right side to represent another chemical bond between sulfur and the second oxygen. In this way, out of the 18 total valence electrons, 4 are utilized, leaving 14 electrons unutilized. Lone pairs consist of electron pairs not utilized in chemical bonding, with each pair comprising 2 electrons. With 14 remaining electrons, we can form 7 electron pairs and mark them on the structure as lone pairs. Also, it's important to note that sulfur, a period 3 element, can keep more than 8 electrons in its last shell, whereas oxygen, a period 2 element, cannot hold more than 8 electrons in its valence shell. One more thing to remember is to always start by marking lone pairs on outside atoms first and then on the central atom. In SO2, each of the 2 outside oxygen atoms will get 3 lone pairs, while the central sulfur atom will receive 1 lone pair, as we only have 7 lone pairs available for marking on the structure. It's evident that the octet is complete for the outside oxygen atoms, but not for the central sulfur atom. Therefore, let's focus on completing the octet for the central sulfur atom now. Sulfur already has 6 valence electrons and needs 2 more to complete its octet. To achieve this, we'll convert 1 lone pair from one of the oxygen atoms, specifically the left one, and transfer it to the sulfur atom to create a chemical bond. After this adjustment, it's clear that both the central sulfur atom and the 2 outer oxygen atoms now satisfy the octet rule. With the octet rule fulfilled, our next step is to calculate the formal charges to determine the stability of the structure. This is the formula we can use to calculate formal charges for the SO2 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Enter the necessary data and assign the values to calculate the formal charges for each specific atom. For sulfur atom, valence electrons are 6, non-bonding electrons are 2, and bonding electrons are 6, so the formal charge will be equal to 6 minus 2 minus half times 6, which equals to plus 1. For left oxygen atom, valence electrons are 6, non-bonding electrons are 4, and bonding electrons are also 4. So the formal charge will be equal to 6 minus 4 minus half times 4, which equals to 0. For right oxygen atom, valence electrons are 6, non-bonding electrons are also 6, and bonding electrons are 2. So the formal charge will be equal to 6 minus half times 2, which equals to -1. The formal charges of both sulfur and oxygen atoms are mentioned, and it is clear that the current structure is not stable, as the formal charges on the atoms are not zero. To fix this, we will proceed by adjusting the distribution of lone pairs and recalculating the formal charges. First, recall that sulfur is a period 3 element and can hold more than 8 electrons in its valence shell. Sulfur already possesses 8 valence electrons and will convert one lone pair from the right oxygen atom, transferring it to the sulfur atom to create a chemical bond. This adjustment is made to ensure that the formal charges on atoms are closer to zero. Therefore, we will recalculate the formal charges to determine if the current structure is more stable than the previous one. We will use this same formula again. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. For sulfur atom, valence electrons are 6, non-bonding electrons are 2, and bonding electrons are 8. So, the formal charge will be equal to 6 minus 2 minus half times 8, which equals to 0. For each oxygen atom, valence electrons are 6, non-bonding electrons are 4, and bonding electrons are also 4. So the formal charge will be equal to 6 minus 4 minus half times 4, which equals to 0. The formal charges of both sulfur and oxygen atoms are mentioned, and it is now evident that the current structure is stable, as formal charges on each atom are 0. Therefore, this structure is the preferable stable Lewis structure of SO2. To represent a pair of bonding valence electrons, we can simply draw one horizontal line. Since there are 2 pairs of electrons on each side, draw 2 horizontal lines on each side, signifying that sulfur is double bonded with 2 oxygen atoms. That's a wrap on the Lewis structure of SO2. If you found this explanation helpful, show your support with a like, share this video, and subscribe to the channel.